Good morning, students. In last class, we discussed about the drain current equation of MOSFET and channel length modulation along with transconductance of MOSFET. Today, we will discuss about the biasing circuits for either it's a MOSFET or JFET. We know, like BJT, the parameters of FET are also temperature dependent. In FET, as temperature increases, drain resistance also increases, reducing the drain current. So, due to this, thermal runaway does not occur in the FET. And we have different types of DC biasing techniques in BJT. Similar to BJT, here also we are having different biasing techniques. This JFET and MOSFET are biased to operate them in saturation or pinch off region. Why? Because to operate FET as amplifier, we must keep the operating point in the saturation or pinch off region. Yes, we know the condition for saturation of JFET. It is VDS is greater than or equals to mod Vp minus mod Vgs for N channel, and VSD is greater than or equals to Vp minus Vgs for P channel. So different types of biasing circuits of FET are fixed bias circuit, self bias circuit, and voltage divided bias circuit. So consider N channel JFET with fixed bias circuit. The figure is shown in the next slide. We'll see. Here VGC is connected to the gate, and due to this, gate channel junction is in reverse bias. So now here we consider the N channel JFET. So due to this, due to this VGG, this gate channel junction is in reverse bias. Similarly, here VDD we are using. This VDD is drain supply. It provides the drain current. And VGG is connected to the gate to operate the junction in reverse bias, and thereby drain current can be controlled. Yes. In JFET we know the gate current Ig is almost equals to 0 because gate channel junction is in reverse bias. So we are considering Ig is almost equals to 0. Yes. So we can say VGS equals to minus VGG. Yes, from this we can observe VGS equals to minus VGG because Ig equals to 0, then Vg equals to 0. So VGS equals to Vg minus Vs. Yes, so it is Vs equals to, we can write minus VGG. Yes, by applying the KVL here, we can write an outer loop. It is VDD minus IDS RD minus VDS equals to 0. From that we can write VDS equals to VDD minus IDS RD. Here RD is the drain resistance. So this RD controls the VDS value, and here RD is also acts as a load here. So RD is selected such that VDS is greater than or equals to mod Vp minus mod VGS. It is always indicating the saturation region. Yes. To use this FET as amplifier, we must keep that FET in the saturation region or pinch off region. Based on that, we are choosing the drain resistance value. Then we can say JFET is operating in the saturation region. So the operating point can be written as VDSQ comma IDSQ, similar to VC comma IC in the amplifier, BJT amplifier circuits. Yes, here we are not considering the RG value because I am not keeping the RG register, gate register, so there is no purpose in this biasing, so I am not considering that one. Sometimes some problems you may observe that RG value, but this RG is, there is no specific purpose here, so here I am not keeping RG value. Yes. So what are the advantages of this gate biasing circuit? Greater voltage gain achieved because negative feedback not present in the circuit. So here source is common, it is common source amplifier. In this it is not providing any negative feedback, so we can get more voltage gain. This is the advantage. And disadvantage is two power supplies we are using. So two biasing supplies are using. One is VGG, other one is VDD. This is the disadvantage in the gate bias circuit. Discuss about the self bias circuit or source self bias. This self bias or source self bias, but that means we are providing the bias through the source RS resistor. So in this we are considering the N channel JFET with source self bias. This is shown in figure in this slide. So we can write, we know VGS equals to VG minus VS. So we know VG equals to 0. Here you can observe VG equals to 0. It is correct to the, we are short circuiting the gain, we short circuit the gate to the source resistor RC as ground. So VG equals to 0 and Vs equals to drop across the RS resistor. We can write it is equals to the amount of current passing through the drain current into source resistance minus IDS into RS. In this voltage drop across, RS makes gate channel junction reverse bias. This technique of reverse bias, a junction through the voltage drop across the resistor, is called self bias. So whatever the voltage drop across the source resistor, that voltage drop makes the channel junction in reverse bias. So why? Because so that source is P type material and gate is P type material. So when voltage drop across the source resistor is more, then due to this more voltage across the source resistor, the gate channel junction becomes reverse bias. So we are not applying the any external bias voltage to this gate to source. Whatever the drop across source resistor, the, the drop at the source resistor will provide the reverse bias to the gate to channel junction. So that's why we are calling this is self bias. So we are providing the reverse bias between the gate to channel by using the source drop, source voltage drop. Yes. So from this we what we can write, VDS equals to VDD minus IDS minus IDS RS value. Yes. And applying the KVL to the outer loop, VDD minus VDS minus IDS RD minus IDS RS equals to 0. From this we can write VDS equals to VDD minus IDS into RD plus RS. So RD is the drain resistance and RS is the source resistance. The two are selected by considering the VDS is greater than or equals to VP minus VGS value. So then only FET will operate in the JFET will operate in the saturation region. Yes. So here we are reducing the one power supply. Yes. In gate bias we are using two power supplies. Here we are using only one power supply. So the advantage of this self bias is single bias supply is used. What could be the disadvantage? So this source resistance or RS provides the negative feedback, thereby we know voltage gain will reduce. Yes, we are providing the reverse bias between the gate to channel by using the voltage drop across the source resistor. But this source resistor becomes the drawback for this circuit. So this source resistance or RS will provide the negative feedback in the circuit, thereby voltage gain decreases. Yes. So why are saying it is a negative feedback? Because if IDS increases, VGS become more negative, you know. Yes. Then reverse bias of gate channel junction increases, channel width decreases, then again IDS is decreases. So initially IDS is increases, finally IDS is decreases. So increased IDS and decreased IDS will cancel each other. So we can say this source resistance is providing the negative feedback. Yes. So this is the drawback in this circuit. So this RS resistor will provide the negative feedback. So due to this, voltage gain will reduce in the circuit. So if I want to overcome this voltage gain reduction or decreases in the circuit, we need to avoid the negative feedback in the circuit. We already know in CE amplifier voltage divider also we are having the same problem, that means negative feedback through the RE resistor. To avoid the negative feedback in the CE amplifier voltage divider circuit, we are using the bypass capacitor. So to prevent the gain decrease in the circuit, we are using a bypass capacitor CS across the or parallel to the RS in the common source amplifier. So just we need to keep the one capacitor parallel to the RS resistor. Then we can increase the voltage gain. Here is voltage divider biasing circuit. So it is similar to the our BJT. So consider n-channel JFET with voltage divider bias circuit shown in the figure. You can observe here. The voltage at the source of JFET must be more positive than voltage at gain in order to keep gate channel junction in reverse bias. So the voltage at source of JFET must be more positive. To keep the gate channel junction is in reverse bias, we must apply the more positive at the source and source compared to the gate terminal. Then gate channel junction is in reverse bias. So we know this R1 R2 forms the voltage divider network. We already know, it is already discussed in the BJT amplifiers. So from this we can write VGS equals to VG minus VC. So voltage drop across VG, it is similar to voltage drop across VB in the BJT. Yes. So VG equals to, we can write VDD into R2 by R1 plus R2. So it is from the voltage division rule. And Vs equals to, we already know the current passing through the RS is IDS or ID, both are same. So I have written IDS. So minus IDS into RS. Yes. So again by applying the KVL at the outer loop, we can write VDD minus IDS RD plus RS minus VDS equals 0. From that we can write VDS equals to VDD minus IDS into RD plus RS. So here R1, R2 should be selected such that VGS lies between the 0 and VP value. Yes, VP is the pinch of voltage, and RD, RS are the drain and source resistance, which are selected by using the condition VDS is greater than VP minus mod VGS value. Clear? Here, what is the advantage and what is the disadvantage? Whatever we discussed in the source self bias or self bias, that RS resistor provides the negative feedback. Due to that negative feedback, the voltage gain will reduce. Here, same advantage and disadvantage are same as self bias, because here also we are using the RS resistor. This RS resistor or source resistor provides the negative feedback. This negative feedback will affect on the voltage gain. So due to this negative feedback in the circuit, it decreases the voltage gain in the circuit. Clear? I said advantage and disadvantage same as source self bias. So this RS is provides the negative feedback and it affects on the voltage gain. Due to the negative feedback, voltage gain will decrease. Yes. And advantage is negative feedback is nothing but IDS increases and IDS decreases. If IDS increases, again VGS become more negative, then reverse biasing of gate channel junction increases, channel width decreases, and IDS also decreases. So increased IDS and decreased IDS will cancel each other, we know. Due to this, IDS remains stable. So we can say it is stable. So the advantage and disadvantage of this circuit is similar to the source self bias circuit. Yes. And this is JFET biasing. If you MOSFETs, so MOSFET, here we are having again two types, enhancement and depletion MOSFET. Enhancement MOSFET can be biased by using gate bias and voltage divider bias circuit. So in enhancement MOSFET, we cannot use the source self bias or self bias, because self bias circuits cannot be bias enhancement MOSFET, because result in VGS is 0 and thereby channel cannot form. Yes. So when I consider the VGS is 0, so channel cannot form, so MOSFET will not work. Yes. Depletion MOSFET can be biased by using any of three biasing circuits. Yes. So when I am using the depletion MOSFET, whatever we are using the JFET, the three biasing circuits can use in the depletion MOSFET, but not in the enhancement MOSFET. So in enhancement MOSFET, we can use only gate bias and voltage divider bias, and we cannot use the self bias because the result VGS is 0, thereby channel cannot form. So when there is no channel, we cannot get the drain current. Yes. So this is about the biasing circuits of FET, either a JFET or MOSFET or depletion, enhancement MOSFET or depletion MOSFET. Clear? If self bias is used, then D MOSFET can be operated only in depletion mode, because it results in negative VGS, so we cannot expect in enhancement mode. Okay, that's why we can use self bias in depletion mode but not in enhancement mode. Okay, thank you.